In this episode, we're going to take the inventory you built in the last lesson and add the missing ingredient that makes it truly usable for security decisions: classification. Inventory tells you what you have, but classification tells you how much it matters, how risky it is, and what rules should apply when people handle it. When beginners hear classification, they often think it is only about labeling files as confidential or public, but in AI governance, classification is broader because assets include models, prompts, datasets, outputs, and dependencies. Classification helps you avoid treating everything the same, which is a common mistake that either slows work unnecessarily or leaves high-impact systems underprotected. It also creates defensible consistency, because you can show that you apply stricter oversight where harm would be greater and lighter oversight where risk is lower. By the end, you should be able to explain what sensitivity, criticality, and compliance scope mean, how they differ, and how to use them together to make predictable, repeatable security decisions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to start is to separate the three dimensions so they do not blur together in your mind. Sensitivity describes how damaging it would be if an asset's information were exposed, misused, or disclosed to the wrong people. Criticality describes how important the asset is to the organization's ability to operate, deliver value, and recover from problems, especially when availability and reliability matter. Compliance scope describes whether specific legal, regulatory, or contractual obligations apply, and it often depends on the type of data involved or the type of decision being influenced. Beginners sometimes assume that sensitivity and criticality are the same thing, but they are not, because an asset can be highly sensitive but not operationally critical, or operationally critical but not highly sensitive. Likewise, compliance scope can be narrow or wide depending on jurisdiction, industry, and contract obligations, and it may apply even when an asset seems low impact from a purely technical perspective. When you keep these three dimensions separate, your classifications become clearer and your governance decisions become easier to defend. Sensitivity is the most intuitive dimension because it ties directly to confidentiality risk, but it still needs careful thinking in AI systems. Sensitive assets include datasets containing customer records, employee information, proprietary research, incident details, and confidential business plans, because exposure would cause real harm. Sensitivity also applies to prompts and outputs, because prompts can include sensitive details and outputs can reveal sensitive information or create sensitive interpretations. A beginner misunderstanding is to assume that only stored datasets are sensitive, while prompts and outputs are temporary and therefore harmless. But prompts and outputs often get stored in logs, tickets, chats, and documents, which makes them part of the organization's information footprint. Sensitivity can also apply to model artifacts if the model encodes proprietary information, learned patterns from confidential data, or unique business logic that would be valuable to competitors. In practice, sensitivity classification answers the question of how careful you must be about access, sharing, storage, and retention. When you classify sensitivity well, you can apply appropriate controls like least privilege, review requirements, and restrictions on where data can travel. A practical sensitivity classification approach requires consistent categories, because inconsistent labels create confusion and uneven enforcement. Many organizations use levels like public, internal, confidential, and restricted, but the exact names matter less than the consistency and the meaning. What matters is that each level has clear handling rules, such as who can access it, whether it can be shared externally, and whether it can be used in certain AI tools. Beginners should understand that sensitivity classification is not a personal opinion. It should be tied to defined criteria like legal obligations, business impact, and the potential for harm. For example, data containing personally identifiable information, PII, may require stricter handling than general internal data, and proprietary product designs may require stricter handling than routine internal communications. Another important point is that sensitivity should account for combinations, because data that seems harmless alone can become sensitive when combined with other data sources in an AI workflow. Classification therefore benefits from being applied not only to individual datasets, but also to how datasets are used together. When your categories and criteria are clear, employees stop guessing and start following predictable rules. Criticality is the second dimension, and it often surprises beginners because it emphasizes availability, reliability, and business continuity rather than secrecy. Criticality classification answers the question of how much the organization depends on the asset to operate, and how much damage would occur if it failed, became unavailable, or produced unreliable results. An AI system that supports customer service at scale may be highly critical because downtime affects customer satisfaction and revenue, even if the underlying data is not the most sensitive. An AI system that supports internal brainstorming may be low criticality because its unavailability is inconvenient but not operationally damaging. Criticality also includes dependency chains, because a system that depends on a single external service might be more fragile than a system with resilient alternatives. Beginners sometimes assume that security is mostly about preventing data exposure, but criticality highlights the business reality that availability incidents can be just as harmful as confidentiality incidents. Criticality classification therefore informs decisions about monitoring, resilience, incident response priority, and recovery planning. When you classify criticality, you are deciding where the organization must invest in reliability and where it can tolerate temporary disruption. A good criticality classification also considers the decision impact of the system, because some AI systems are operationally critical even when they do not directly control core infrastructure. If a system influences hiring decisions, lending decisions, or safety-related decisions, the organization may depend on it for important processes, and failures can create significant harm. Criticality can also be tied to time sensitivity, meaning how quickly the organization needs the system restored after failure. Some systems can be down for hours with limited impact, while others create immediate operational problems when they fail. Beginners should understand that criticality is not only about the number of users, because a system used by a small team can still be critical if that team performs essential functions like incident response or compliance reporting. Criticality also changes over time because a pilot system might become operationally critical when it is integrated into daily workflows. This is why criticality classification should be reviewed periodically and updated when use expands. When criticality classification is accurate, it guides prioritization during incidents and helps leadership understand where continuity planning is essential. Compliance scope is the third dimension, and it is often the most confusing for beginners because it involves obligations that come from outside the organization. Compliance scope answers the question of whether specific rules apply to an asset because of what it contains, how it is used, or where it operates. For example, an asset containing personal data may fall under privacy obligations, while an asset used in a regulated decision context may require transparency, auditability, and oversight. Contract obligations can also expand compliance scope, such as partner agreements that restrict data sharing or require certain security controls and evidence. Beginners sometimes assume compliance applies only to certain departments, but compliance scope is about the asset and its use, not about who built it. A vendor AI service processing sensitive data can be within scope even if the organization did not build the model itself. Compliance scope also depends on geography and market because the same system used in different regions may face different obligations. When you classify compliance scope, you are identifying where additional documentation, approvals, and evidence collection are required to remain defensible. To classify compliance scope effectively, you need to link assets to obligations in a structured way rather than relying on memory. A practical approach is to define triggers that place an asset in scope, such as processing certain data categories, supporting certain decision types, or being used in customer-facing contexts with specific promises. You then map those triggers to required controls and evidence expectations, so scope becomes actionable rather than theoretical. Beginners should be careful about the misconception that compliance scope is only a legal question, because in AI governance it becomes a governance and security question when you must implement controls and prove they exist. For example, If a contract requires that partner data not be used to train models, compliance scope includes training datasets, prompt logs, and model adaptation workflows, not just the final system. Another example is when transparency obligations require that decision processes be explainable or reviewable, which affects documentation and monitoring requirements. Scope also includes third parties, because obligations often extend to vendors and service providers. When compliance scope is mapped clearly, you can apply consistent requirements and avoid surprises during audits or contract reviews. Now that the three dimensions are clear, the next step is understanding how they work together to drive governance decisions, because classification is only useful if it changes behavior and control selection. A highly sensitive, highly critical system within broad compliance scope should have the strongest controls, the most frequent review, and the clearest ownership, because the consequences of failure are high in multiple ways. A low sensitivity, low criticality system outside major compliance scope can move faster with lighter oversight, which supports business agility and reduces pressure to bypass governance. Many systems will fall somewhere in the middle, and classification helps you decide what is proportionate. Beginners often struggle when everything feels important, but classification creates a disciplined way to say this is high impact, this is moderate, and this is low, with defined consequences for each category. This is also where consistency matters, because classification should be applied the same way across teams, so oversight is fair and predictable. When classification drives consistent tiers of control, governance becomes scalable rather than ad hoc. That scalability is essential as AI use expands. Classification must be applied to each asset type in the inventory, not only to the overall AI system, because risk can hide in components. A dataset might be restricted sensitivity because it contains personal data, while the model itself might be moderate sensitivity but high criticality because it powers a key workflow. A prompt template might be high sensitivity if it includes embedded access to internal knowledge sources, even if users think it is just a helpful instruction. A dependency might be high compliance scope if it is an external service that processes regulated data, even if the internal system is otherwise well controlled. Beginners should understand that system-level classification is helpful, but component-level classification is what enables precise controls, like restricting access to the most sensitive datasets while allowing broader access to less sensitive components. Component-level classification also supports change control, because changes to high-scope or high-sensitivity components should trigger stronger review than changes to low-risk components. This approach reduces both over-control and under-control by applying rigor where it matters most. It also improves evidence, because you can show that your governance is targeted and thoughtful rather than blanket and vague. When each asset type is classified, decisions become more defensible. A major beginner misunderstanding is thinking classification is only about confidentiality, which leads to ignoring integrity and availability risks that are central to AI trust. Integrity risk matters because tampered training data or corrupted configurations can cause harmful outcomes even if no one ever steals the data. Availability risk matters because downtime or degraded performance can disrupt operations and can force teams into unsafe workarounds. Classification should therefore influence controls for integrity and availability as well, especially for high criticality assets. For example, if a model is operationally critical, the organization may need stronger monitoring, more disciplined change control, and clearer recovery planning to maintain reliability. If a dataset is high sensitivity and also high integrity importance, the organization may need stronger controls to prevent unauthorized modification and to validate data quality over time. Beginners should see this as a balanced security approach, because focusing only on secrecy misses the ways AI systems can cause harm through incorrect or unstable behavior. Classification helps you prioritize which assets require stronger integrity checks and which assets require stronger availability planning. When integrity and availability are considered alongside confidentiality, classification becomes a more complete risk management tool. Classification also needs a maintenance strategy because assets change and their classifications can become wrong if they are not reviewed. A system that begins as a low-risk pilot can become high criticality when it is integrated into daily operations. A dataset that begins as internal may become high compliance scope when new data sources add personal information. A dependency that was stable may become riskier when vendor changes increase retention or expand data processing behavior. Beginners should understand that classification is not a one-time label. It is a living attribute that must be updated through governance routines. This is why classification should be integrated with intake, change control, and periodic review, so classification changes are triggered by real events rather than discovered during an audit. Ownership also matters, because someone must be responsible for updating classifications when the system changes, and that responsibility should be defined clearly. When classification is maintained, the organization can prove it is actively managing risk rather than relying on old assumptions. That active management is what makes governance credible over time. From an evidence perspective, classification becomes especially powerful when it is tied to handling rules and review requirements that can be verified. If an asset is classified as restricted sensitivity, there should be clear evidence of stricter access control, tighter sharing rules, and appropriate retention boundaries. If an asset is classified as high criticality, there should be evidence of monitoring routines, incident response prioritization, and recovery planning. If an asset is in compliance scope, there should be evidence of required assessments, approvals, and documentation that meets obligations. Beginners should recognize that classification without consequences is just labeling, and labeling alone does not reduce risk. The value comes when classification drives predictable actions and produces artifacts that demonstrate those actions occurred. This also reduces conflict, because teams can point to classification rules rather than arguing from personal opinion about what should happen. Classification, therefore, becomes both a security control and a governance communication tool. When classification is linked to evidence, it supports defensibility with regulators and contract partners. As we wrap up, classifying AI assets by sensitivity, criticality, and compliance scope is the step that turns inventory from a list into a decision engine. Sensitivity tells you how damaging exposure or misuse would be and drives confidentiality-focused handling rules for data, prompts, outputs, and sometimes model artifacts. Criticality tells you how important the asset is to operations and drives availability, reliability, monitoring, and recovery priorities that keep the business running. Compliance scope tells you where external obligations apply and drives documentation, approval, and evidence expectations that keep the organization defensible. When these dimensions are applied consistently and at the component level, you can target controls precisely, avoiding both over-control and under-control. When classification is maintained through intake, change control, and periodic review, it stays accurate as systems evolve and dependencies shift. The core beginner takeaway is that classification reduces guessing by making risk and obligation visible, and that visibility is what allows AI governance to be consistent, scalable, and trustworthy.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.